So, due today is the homework quiz part 2. Every week there's usually a homework quiz and a discussion. The discussion is always due on Sundays, so it's technically due down here on the same day as your exam, but you can just do it today and get it out of the way. So you need to post or reply twice for the discussion. It's technically not due till Sunday, but I recommend you do the discussion before you take the exam. So you might see something that might help you that other students have posted. So we have covered everything in the chapter. So today's a review day. So I have posted an Exam 1 review with definitions and then example problems on the topics that you'll see on the exam itself. So the very first part, the definitions, I'm going to leave that for you guys to fill out. You can get the definitions from the PowerPoints. I go through the definitions, so I have the PowerPoint videos that I've posted in every folder where I talk about the definitions, but I also have, if you've seen under course content, I have a folder that just says PowerPoints on it. That's where I'm going to post all the PowerPoints that aren't videos, because I know the videos are rather large documents, so you can just open those up and scroll through them slide by slide to find the definitions you need, instead of watching the video and trying to catch me in the right spot. Okay, so I would go through and write those down. I didn't fill them in for you because it's usually helpful just for your brain to write things down. It helps you remember. So I'm going to skip that part, and we're going to move on to recognizing the steps of the scientific method. Okay, so you'll notice the scientific method, that's one of the definitions that you need to know. You also need to know how to apply it. So when we talked about the scientific method, there are several different steps. It started with an observation. Then you would ask a question. From there you would come up with a hypothesis. You do experiments, data collection, try to prove your hypothesis true, and hope that it became a theory. Okay, so we're going to take that scientific method chart, flow chart in our heads, and we're going to apply the steps to these following scenarios. So the first scenario, if you're following along virtually, you're probably going to want to have your Exam 1 review open, because I'm not going to be writing these big paragraphs up here. So the first one is wondering what type of fertilizer works best. So when you're looking at a situation, look for clues that help you figure out what step of the scientific method it is. So for this first one, the clue that I see that jumps out at me is wondering. If you're wondering something, would that be an observation? Would that be a question? Or a hypothesis? What do you think wondering is? If I'm wondering something, it's most likely a question. Okay? Wondering is not an observation because you're not physically observing it in any way. So for observation, you're looking for touch, taste, smell, your senses. Wondering is not a sense. Okay? It's a brain activity. So it would be a question. And the reason it's not a hypothesis is because you're just wondering what type. You're saying what type of fertilizer works best. You're not predicting anything. And for it to be a hypothesis, it would need to be a prediction of some sort. So wondering would be a question. So the second one, a scientist predicting that mice will grow larger if given vitamin C. So predicting, exactly. That's the word that's going to help you figure it out. So predicting, educated guess. So what step would that be? Hypothesis. You are predicting, you are guessing. There's no proof behind it yet, so it's not a theory. All right, so number 3, knowing that mice will grow larger given vitamin C due to supporting evidence and experiments. So this one's kind of a dead giveaway. We're saying not only do you know it, but you have proof, you have evidence, you have experiments. Okay, so this is that last step of the scientific method where you have taken your hypothesis and supported it, and your hypothesis becomes a theory. And last but not least, number 4, feeling the texture of the soil in a predominantly dry climate. So it's giving it away here is feeling. Okay, you're using one of your senses, you're touching. So if you're feeling something, you're using one of your senses, you're just starting the process and you are observing, or observation. So once you feel it, you observe it, then you might come up with a question. Why is the texture grainy? From there you would guess why, an educated guess, and we run the hypothesis, so on and so forth. So that's how we're going to be using the scientific method. You need to know the definition of it, because it is an organized approach to solving scientific problems, but you also need to know how to apply it given situations. I think I have 2 or 3 multiple choice questions on the exam for that. So, for the exam itself, you have an hour and a half, 90 minutes to finish it. It is all multiple choice. I don't think I have any fill in the blanks. I cannot remember for the life of me the number of questions, so I'll post the number of questions in an announcement once I open the exam. One thing I did want to mention about the exam, it's due Sunday, September 13th by midnight, but it's going to be open starting Friday morning. So if you're feeling confident, you studied this week, and you want to get it out of the way Friday and enjoy your weekend, it'll be open all day Friday for you to do that. You only have one chance to take it, and it shows just one question at a time instead of showing all of them like most of the quizzes do, but you can backtrack if you want to. So, other than the number of questions, it's in the 30 range. I can't remember exactly how many, but it's in the 30 range. So I will include that in the announcement when I open the exam. All right. Standard SI units for mass, length, time, and volume. So go back to, I believe it was the very first PowerPoint. Look at SI units, so that's that when we signed the Treaty of the Meter and all people in the scientific and mathematical fields agreed on using metric units. And they agreed upon 4 fundamental quantities, the mass, length, time, and volume. So you'll want to look up those units, possibly write them down. I mean, this is an open note test. I can't be at home with you telling you not to look up anything. So doing a really good job of filling this out and the definitions on this review, this is going to be a useful aid to have next to you during exam time. And when you go to take the exam, have this out, have your calculator out, have your conversion sheets out or open on your computer. Okay, be ready once you start it so you can get it done in the allotted time. And in the past, usually the Chapter 1 exam only takes people a half hour to 45 minutes. So I'm giving you the extra time to look up this stuff, but that doesn't mean you don't need to know how to do it. You're not going to have time to watch a video on how to do a conversion in the middle of the exam. So I recommend that you at least know how to do the calculations necessary. All right. Now let's look at significant figures. I also posted a folder with practice worksheets on significant figures, scientific notation, conversions, and density. So if anybody just wants more practice with those, the answer key's in there with them as well, so you can do more practice. But enough about announcements, let's try some problems. So sig figs. We need to be able to count the number of sig figs given a number. Okay, so some of the questions are just as easy as this. I go, how many sig figs in this number? And then you need to just count them and select the appropriate choice. So you need to know the rules for counting. the past, I have people work on this for the first half hour of class, and then maybe people come up to the board and answer questions. But I don't think you do that unless you want to. So instead, I'll just do it all up here on my own, with help, of course. So let's look at the first one. We're counting sig figs. So the rules for counting, if it's not a 0, it matters. You always count from left to right. So I'm starting at the 2. I know that counts because it's not a 0. Do these other 2 zeros count? So zeros sometimes count, and there's 2 set of rules when they count. The first is, if the 0 is between 2 non-zero numbers, then it counts. The other rule says zeros can count if there's a decimal and you've already started counting. So in this one, since there is a decimal and we started counting at the 2, all the zeros after the 2 will count. So we do have a total of 3 sig figs. So now in this next one, that rule, the fact that there's a decimal can sometimes confuse people, because students will see the decimal and they'll go, oh, zeros count because there's a decimal. But you haven't started counting, exactly. You need to start counting first, and you can't start counting until you get to your first non-zero number. So you have to keep going until you hit a non-zero. My first non-zero number is way over here at the 9. So these 2 9s count. None of the zeros before them will. If I had zeros after, they would, but I don't. So it's just 2 total significant figures. All right, 5,000. So start counting. I know the 5 counts. Now we hit those pesky zeros again. So do these zeros count? Well, we said the 2 rules. Right? Is there a decimal point? No. There's a comma, and commas are not the same as decimal points. So commas, zeros don't count. Decimal, they would, as long as we started counting. So it's just 1. Okay, I could have 10 more zeros after this, but if there's no decimal telling me those zeros count, it's just that first digit, that non-zero digit that counts. All right. The next one, so we have 0.0004170. So count from left to right and don't start counting until you get to your first non-zero. So I'm not going to start counting until I get to the 4. The 1 and the 7 both count because they're not zeros. It's the zeros that sometimes count. So to figure out if this one counts, apply your rules. Do I have a decimal? Yes. Have I started counting? Yes. So that 0 counts. Zeros before do not, because we don't start counting until the 4. It's a total of 4 sig figs. Last one, 800. But notice, decimal point at the end. So why do you think that decimal point's there?
To make the zeros count.
To tell you those zeros are important. They count. Okay, so this time we start counting at the 8, and the zeros after the 8 do count, because someone put a decimal there to say those ones matter, don't forget about them, for a total of 3 significant figures. All right. So let's move on to a calculation problem. So the other stuff you're going to need to do is calculate and apply sig figs to the calculation. Addition, subtraction, multiplication, division. Now the tricky thing here is you have to remember the rules and that the rules differ. Okay, so if we have addition and subtraction, the rules are to count the decimal places. And then pick the least. If you're doing multiplication and division, which is usually what we do, because when we do conversions, when we do density problems, that's all multiplication and division. So we get used to counting the significant figures as a whole. and picking the lowest. And so sometimes that makes us forget that when we're adding and subtracting, the rules are different. So that's why I wanted to do an addition subtraction one. Okay, so we're counting just decimal places, so not sig figs as a whole. So I'm going to start at the decimal place for each of the numbers involved, and I'm just going to count how many there is.
2.
First one, 2. Correct. So 2, and I'm going to put DP instead of SF because it's decimal places. Total sig figs would have been 3, but I'm not paying attention to that, just decimal places. So how many decimal places in this one?
No.
The 0 does count, yep. So for decimal places, even if it's a 0, it matters. It doesn't matter that it's not a significant figure because we're looking how many placeholders after the decimal, and there's 3 in this case. The last one would be 6. That's a lot. All right. So now when we calculate our answer, I have my calculator here somewhere. Once you calculate this out, you want to round to 2 decimal places. All right, so I get 2.6936 something or other. And a couple other digits after that. But I'm going to stop there because I won't have to go further than that. So what we want to do is pick the smallest, always the smallest. So which number is the smallest for decimal places? 2. The 2 decimal places. So I'm going to go over here. I'm going to start at the decimal and count 2 places out to the 100th spot. Look to the number next to it. Does that stay a 9 or round up? It's going to stay a 9, so I get 2.69. So this is the correct answer to 2 decimal places. Now I want to point out why this is important. If I were to count significant figures on accident, instead thinking this is the multiplication and division problem, my total sig figs, we'll do those up here in red. For this first one, there's going to be 3. That 0 counts, right?
2.
Here there would just be 2 because we start counting at the 9. And then here, 4. So if I went ahead and picked my smallest, I would have said that I need 2 sig figs as a whole. So you would have went over here and said 1, 2. So you would have got 2.7. And that's incorrect because you applied the wrong set of rules. So the takeaway here is pay close attention. What order of operations are you applying? And then apply the rules accordingly.
But it asks for number of sig figs.
It asks for what?
Number of sig figs.
Oh, so the total answer asks for number of sig figs?
Well, it has like another.
Okay, so once you get your final answer, count the total sig figs in it, if that's what the question's asking for. Sorry, I missed that part. So all of these are not 0, so they all count. So how many total sig figs in the answer we should be getting? 1, 2, 3. So we went out 2 decimal places, and that caused our answer to have a total of 3 sig figs. I wanted to practice a rounding one because sometimes there are issues with this type of rounding. And you'll see what I mean when we do the problem. So if I asked you to take the number 185, and I said I wanted you to round it to 2 sig figs. So how many significant figures does it have right now? 1, 8, and a 5. So those all count, so it has 3 sig figs right now. Well, if I wanted you to report it in just 2, you always start from left to right, so you're going to say the 1 counts and the 8 counts. Don't forget to look to the number next to it. Since it's a 5 or higher, you're going to round up. So the 8's going to become a 9. So this is the mistake that's most often made. Because you're like, okay, 2 sig figs, I needed to round up 19. That's incorrect. Because this was 185. It was in the hundreds range. You can't go from the hundreds down to 19. So what you need to do is you need to put a number after the 9 that's not going to be significant, but will help this stay in the 100 range. So what's the only number that we can use that's not always significant? A 0. So you need to make sure to add that placeholder 0. Because now I have 2 sig figs, that 0 doesn't count because there is no decimal, and I'm still in the 100 range. I'm at 190. So this would be the correct answer. And it's multiple choice, so I'm going to be giving you plausible choices. Okay, these would probably be the choices I would give you. I'm going to give you some wacky out of their choices, so you gotta pay close attention. All right, calculate again. So let's do another calculation. I'll do it over here where my rules are. So we did an addition and subtraction. Now let's do multiplication and division. So the particular one on here is a division problem. So we're taking 0.2150 divided by 0.0060. So since we're dividing, we're applying the rules down here. We're counting the sig figs as a whole, and we're going to pick the lowest. So let's count the sig figs first. So you count how many sig figs in every number used in the problem, and then pick the smallest. So the top number, the numerator, start counting at the 2. 1 counts, the 5 counts. Does that last 0 count? It does because of the decimal. So 4 sig figs. In the denominator, how many sig figs in that number?
2.
Just 2, yep. You start counting at the 6 and then the 0 counts. Because there's a decimal and we started counting. So how many do we want in our answer? 2, because you picked the smallest. So once I calculate that out, once I do that division, I'm going to round it to 2 sig figs, much like I did over here. 0.2150, 35.3333. Repeating. Okay? So you don't want to report that answer. You want to make sure you have just 2 significant figures. So start counting left to right. 1, 2. So I'm stopping at the 5. But I'm going to look at the number next to it and figure out, does that stay a 5 or do I need to round up? Round up in this case. So it's going to be 36. For a total of 2 significant figures. Let's try scientific notation. I'm just going to do 2 of these because I know a lot of calculators can just put it in scientific notation for you. So this might not be something you have to work too hard at. The only thing is you need to take into account significant figures when you go into scientific notation, and not all calculators take into account significant figures. So for the first one, 1A, you have 0.005621. So we're going to take that and put it in scientific notation. And the rules of scientific notation say that you want your decimal to be in a spot that there's only one non-zero number to the left of the decimal. So before I do that, I'm going to count my sig figs to make sure I have the same amount in my answer. So counting the sig figs, we don't start till we hit the 5, and then the rest of the numbers after that are all not zeros. So they all count for a total of 4. So now, what I want to do is move that decimal so that there's just one non-zero number to the left. So what two numbers is that decimal going to go between?
5 and 6.
5 and 6. Okay, so I'm going to get 5.621 times 10 to the, now we need to figure out the exponent, and that is how many times you move your original decimal to the new spot. 2, 3. So we move it 3 times. Before you are completely done, check though, because sometimes that exponent's positive and sometimes it needs to be negative. It needs to be negative in this case. Why?
Because you moved to the end of the number, not to the
Right, so you can remember it 2 ways. Because you move to the right to get it to where it needs to be, or the original number was less than 1. Both rules work. Whatever one sticks in your head. All right, next one, count sig figs first. So, just going to put lines on all the non-zero numbers. Are these zeros going to count?
No.
No, there's commas, not decimals, so it's just 5. Not the right one. So I want to make sure there's 5 in my answer when I'm done, so I can lock these zeros off. I don't need to put them in my scientific notation form. So now I need to put the decimal, so there's one non-zero number to the left. So where am I going to want my decimal at?
Between
8 and the 4. So, I need to drink water here. To figure out the exponent, it's how many times I move the original decimal point to where it is now. But there is no decimal, so where do I start?
at the end.
At the end. Yes. I think I already heard you say 7. Just ahead. Does it stay positive or go negative? So this time we moved to the left. The original number was greater than 1, so it remains positive exponent. All right. So this next one is a combo. We're going to calculate this. It's multiplication. We're going to report our answer to the correct sig figs, but we're also going to report it in scientific notation. Like I said, some calculators will just put it in scientific notation for you. But you need to make sure that your calculator included sig figs because it does not always do that. So 1870 times 0.0066. Oh, that's a lot of zeros. This is the point where I wish I had a fancy calculator that put it. Yeah? That's what my calculator gave me. But let's count sig figs. Make sure we have the correct amount first. So this original number, 4. This one, 3. So we want 3 in our answer. And right now, I do have 3 in the answer my calculator gave me. So now I just want to make sure it's in scientific notation. So if I don't have a calculator that does that for me, I'm going to take that decimal and put it, so there's one non-zero number to the left. I'm going to move it 7 times to get it there. So 6.73 times 10 to the I say? So we're trying to get it there? Yep. Negative or positive exponent? Negative. So that was all review from the very first part of the chapter. So now let's get into the conversions. This is usually the harder questions that you'll see in the exam. So for conversions, we start 22.305 grams. We're going to take that and we are going to convert it into kilograms first. And if you flip it over, you'll see we're going to do milligrams and pounds as well. So, important thing to remember when you're doing conversions is recognize what type it is. Because depending on the type, you're going to be converting it differently. If it's metric to metric, so if they have a letter in common in the unit portion, you're going to just move the decimal point. Okay, so metric to metric is going to be the KHD, King Henry died, drinking chocolate milk, that guy. If it's English to metric, you're going to go to a conversion table and find the appropriate conversion and do the railroad tracks. Okay, so what type is this? Letter in common, so it's metric to metric. That letter in common, that's what goes in your empty space when you're using this scale. So in this case, a G. So we are at the G, we're at grams, and we want to get to kilograms. So we're going to use this to figure out how many times we move the decimal and in what direction. We said we were at the grams, and then we're going to go to the kilograms. So to get there, you want to count each of those prefix letters as one decimal place. So to get to decagrams, that's once, hectograms is twice, kilograms is going to be 3 times. So I'm moving that decimal 3 times, and I just went to the left. So I'm going to do the same thing over here. Start at the decimal and move it 3 times to the left. What's going to go in that empty space? 0. So 0.0220305 kilograms. Notice I kept all the significant digits. I didn't round because I was sick of writing. Okay, the original number had 5, so I want to make sure that my answer also has 5. All right, so the next one is asking, with the same number, to go to milligrams. A little bit of practice with metric to metric, because you'll notice, letter in common, we're using that scale again. The letter in common is a G, so I'm just going to leave that G there. We're starting at the G and going to the M. So we're going the other direction this time. So starting here, going to where the M is. So this time we're moving the decimal point 1, 2, 3 times, but to the right. So I start at the decimal just like I did up here, but I'm going 3 times to the right this time. So my decimal is going to end after the 5 there. So this is going to become 22,305 milligrams. Do you have any questions so far? I don't want to go too fast, but I also want to do as many as I can. Okay, so let's take this number yet again and go to pounds. So this time, no letter in common. Okay, I can't use this scale anymore. I can't just move the decimal. I need to find a conversion factor from my tables that works. And what is it? 453.6 grams in 1 pound? Do you have your conversion table here?
Yeah, it's right here.
Okay, I don't have one. I gave my last one away last class.
Grams to pound is, yeah.
Okay. So you would look in your table, you would find one that goes from grams to pounds. Then, since this is your conversion factor, you need to do the railroad tracks, that plus sign. What's going to go in this upper left-hand corner is always the number you're trying to convert. So I'm going to put my 22.305 grams here. What's going to go here in a fraction form is the conversion factor I found. I just want to make sure to put it so that I'm canceling out what I don't want and keeping what I do. So grams is going to go on the bottom, right? We want grams, the 453.6, down here in the denominator so that they're on opposite sides of the horizontal line and they cancel. That's going to put the 1 pound on the top. So essentially we're going to be dividing here. So 22.305 times 1 divided by 453.6. Now we need to pay attention to sig figs. We said there was 5 in the original number, right? There's still 5. So whatever we get for our answer, we want to make sure we're including 5 significant figures, no more and no less than that. Zero point 0.049173. All right, so we don't want all those digits, so let's count the ones we do want. We said 5. So we don't start counting until we hit our first non-zero. So we start at the 4. So 1, 2, 3, 4, 5. Stopping at the 3, I'm looking at the number next to it. Does that remain a 3? Yes, it does. My answer. This is the correct amount of digits, but I'm missing something, and that is the units. So this is pounds. So only units left when I did the conversion. Since I only have time for one more, I'm skipping number 2. So that it's just more conversions like this. I'll post a key though, so you can do those on your own and check your answers. And I'm going to do a density problem. So on the back, the very last page, there's 2 density problems and a % error problem. So I'll do one of the density ones. Whichever ones I did not do on the board, like I said, there'll be an answer key. So you can always do those on your own and check your answers. All right, so I'm going to do the first one. Density of acetone is 0.791 grams per mil. So I'm not going to write the whole question down since you should have it in front of you. I'm just going to write the values we need. Then it says calculate the mass of 5.4 liters of acetone. Okay, so what 5.4 liters, is that the mass or is that a volume? So density is mass divided by volume. That's why the units are grams for mass and then milliliters for volume. So if you're ever not sure, you can look at the units to help you figure out what the number is representing. So in this question, it's saying calculate the mass. So what that tells me is mass is my unknown. Mass is my question mark. That's what it wants me to solve for. That 5.4 liters, that's going to be my volume. And I know this by default, but also because of the units, liters. So if I'm solving for mass, this equation needs to be rearranged. And we had talked about using this DMV triangle. And when you're trying to solve for a variable other than D, all you do is you cover that variable up with your hand. So if I'm solving for mass, I'm going to cover up the M. And then what I'm going to do is I'm going to apply the order of operations to the next 2 digits. So what that means is, if I cover up the M, remember vertical lines are multiplication lines. Horizontal lines are division lines. So if I cover up the M, my equation becomes density times volume. So this is where I want to plug these numbers in. Before you plug the numbers in, make sure your units match. My density is in grams per mil. My volume, though, is in liters. What does it need to be in order to use this equation? I can't be in liters. I need to be in milliliters because I need to match the units on the density. So I have to convert that, but luckily it's just moving the decimal. Because it's metric to metric, the letter in common is L, so that's why I put an L there. I'm going to go from the L to the M in this case. 3 times to the right. 1, 2, 3. Empty spaces will go zeros. So that's 5,400 milliliters. So I want to use this value in milliliters in that equation. So now I just plug in. My density, I didn't have to convert that. It's the 0.791 grams per mil. I'm going to multiply that by my volume, which I've converted to milliliters. And you can see why now that I have it written out. Is because I need the milliliters to cancel. If I still had it in liters, they wouldn't have canceled. So multiply that out. 791 times 4271.4. So the units on it are going to be grams, because that's the only units I have left. It's also the acceptable units for mass. But I also need to take into account my significant figures. You look at the original numbers in the problem and count. So density has 3. My original volume had 2. Always pick the smallest. I want 2. But I'm not just going to write 42. I'm not going to write 42 at all, because I need to look at the number next to it. 43. But I can't go from 4,000 down to 43, so what am I going to put here? Zeros. So 4,300 grams. I still have 2 sig figs, and I'm still in the 4,000 range. So there's one more density problem and the percent error problem. So I will post a key for this, and I can work those problems and post a video for Friday's class on that as well. Questions?